Welcome to Pomodoro Joe for Wednesday, March 29th, 2023. Today we're doing LeetCode problem 1402, reducing dishes. This is a hard problem. A chef has collected data on the satisfaction levels of his end dishes. Chef can cook any dish in 1 unit of time. Like time coefficient of a dish is defined as the time taken to cook that dish, including the previous dishes, multiplied by its satisfaction level. So time index I multiplied by satisfaction index I. Return the maximum sum of like time coefficient that the chef can obtain after dishes preparation. Dishes can be prepared in any order, and the chef can discard some dishes to get the maximum score. All right. So let's take a look at these. In example 1, we've got -1, -8, 0, 5, -9. And the output is 14. How do they get that? So after removing the second and last dish, so they skip -8 and -9, the maximum total, like time coefficient, will be equal to, let's see, they're putting the time value second, so the time is 1, 2, 3, and it's -1 times 1, 0 times 2, and 5 times 3. So that gives us 15 minus 1, 14. All right. So for the second example, we'll do 2, then 3, then 4. So 2 times 1, 3 times 2, so that's 6 plus 2 is 8, and 4 times 3, so that's 1, 2, 3, so that's 2, 6, 12, which gives us a total of 20. Yep. -1, -4, -5, they're all negative, so let's not cook any dish, and we'll return 0. Yep. Okay. So with that, we will put 25 minutes on the Pomodoro timer and get started. So I think for this one, it looks like it's more of a math problem. But with this math problem, we want to maximize our value or our score. Now, every positive dish will give us a positive impact to our maximum score. So we'll prepare every single positive valued dish. Now, the 0 valued dishes don't directly give us a better score, but if we put zeros at the beginning of our meal, so we can serve our 0 dishes first, and those will increase our multipliers for the higher valued dishes. So it looks like I want to serve the highest valued dish at the end of the meal, so it gets the highest multiplier. Then I'll serve the lowest valued dishes that are still non-negative at the beginning of the meal. They'll have smaller multipliers, but that's okay because they're smaller numbers. Then for the negative dishes, I may or may not want to serve those. The negative dish that I serve will still impact our score. It will have a negative impact on the score in the small term or in the short term, but it might increase our multipliers enough to offset that negative impact. So if we serve, like in this first example, a -1, it will impact our score by subtracting 1, but it bumps up all of the other multipliers of the positive dishes. So our 5 goes from being just 5, or 5 times 2, to being a 5 times 3. So that negative number is offset by the positive impact it has on serving a higher value dish later in the meal. Okay, so let's see. Let's get started here. We'll have some result, and we'll set it equal to 0 to start, and we will return our result at the end. Now, since I want to serve our dishes in sorted order, I'll sort my satisfaction here. I'll call it dishes. So we'll sort our dishes from smallest value to highest value. So that will be the most negative value to the highest positive value. Now let's see, I only want to serve positive dishes or non-negative dishes at first. So let's start by just finding all the non-negative valued dishes. Let's see, so we'll start with some index, and we'll put it at the end of our sorted dishes. Now let's do this. Let's have our max index. That's going to be the length of our sorted dishes minus 1. So starting at index 0, we'll increase our index until we find our first non-negative number. So all right, so starting at index 0, while we're less than our maximum index, and while we don't have any positive dish, so while our sorted dishes at this index is less than 0, we'll increase our index by 1. So this should give us the first index of a non-negative dish. So our current dishes are going to be equal to our sorted dishes from this index to the end. All right, now we have all of our non-negative dishes in sorted order. This is our base score. The next thing we'll do is start adding negative valued dishes to the beginning of our current set of dishes to see if it gives us a better score. So let's write something that gives us a score here. So we'll have some function that will score our dishes. Let's see, and the score of the dishes over here is going to be the time times the satisfaction of that dish. So we need some time, and we'll start it at 1. And we'll have some overall score, and we'll start it at 0. So for our dish in our dishes, our score will increase by time times our current dish. And then we need to bump our time up by 1. All right, and at the end, we will return this score. Okay, so this gives us a way to actually score our dishes. So at this point, we've got all our non-negative dishes. Let's get our base score. So our result will be our base score here for these current dishes. And now we can start adding these negative dishes. All right, so we're going to start at our current index minus 1. We don't want to include our current dish again, so we need to actually decrement our index. And then while our index is greater than 0, we'll be going down to more and more negative dishes here. Oh, I can do this. Instead of saying while it's greater than or equal to 0, I'll just say while it's greater than 0, and then we'll decrement our index inside. That'll be easier. Okay. So now we need to add the dish at this index to the front of our current dishes. So our current dishes will now equal this dish appended to the front, or prepended to the front of our current. Now, in order to do this, I actually need to wrap this value in another list so that we're doing a list operation, appending the current list to the end of this list of one element. This has the same effect as saying put this index valued dish at the front of our current dishes. So now we update the result. The result will equal the maximum of our current result or the new score. Let's just take a look here and make sure this is all right. So we start with result 0. We sort our dishes from low to high. We find where do we get to our first non-negative dish, and that will start our current list. So we have all the non-negative dishes first. We'll calculate the score. The score is calculated by multiplying the dishes value by the time, and that's about it. All right, now that we have our base score, we can start adding in our negative valued dishes to see if it gives us a better result. Let's see if this works. Okay, and we are missing something. We output -1. So this result, we actually also need to do max of our current result, or the score. Let's try that. Okay, that works. That was a little bit tricky. All right, so now that we have this, let's give it a shot. And we pass. So we do okay. We beat 41% for runtime and 46% for memory. Not too bad. Let's see if we can improve upon this. All right, let's go back to our description here. All right, where are some places that we can improve? Well, I still think we need this sort. We still need to find our best dishes first, but we have these two while loops. I wonder if we can merge those into one while loop. Yeah, let's try that. Let's move our score out of here. Let's move this up at the top, make it a little bit easier for us to read our different loops together. Okay, so this is our score up here, and this is our basic algorithm. We've got these two while loops separated by this sort of calculation of our current result. Let's make sure this still works before I keep going. Okay, so that still works. Let's see if we can merge these two loops into one loop instead of doing these two separate loops. That might give us a little bit of a gain. So let's see, for this one we're actually counting up. For this one we're moving down. We could flip this around and we can move down. So let's try that. Let's start with that. So our index will now start at our max index. All right, so while the index is greater than 0, now internally we'll have to check to see, are we at a positive dish or a negative dish? Since we're starting at the max, I think we have to do less than or equal to 0, or greater than or equal to 0. Okay, now we say, let's see, if our dish is a non-negative dish, we will add this to our current dishes. Instead of saying index to the end, basically we'll just be adding it. So, hey, this looks really similar. We're just going to keep adding dishes to the front of our list of dishes. Yeah, this looks really similar. Let's just do that. Let's just keep adding, let's basically just do this right here. I think this might work. Let's just check it. So while our index is greater than or equal to 0, we're going to start at the end. We're going to add our index. We need a current, so we need to start with some empty current list here. So we'll add that dish to the beginning of our current. So we'll keep pushing things on the front of our current and then recalculate the score. I think this will work. It might be more costly though, because we'll be calculating more scores. We're calculating a score basically for every dish that we add. Let's see if this still works. It seems slow. Oh, it's because I'm not decrementing my index. Of course, I still need to decrement my index. Right. Let's try that. Okay, that still works. I'm curious. I don't think this will save us anything, but it makes our code a lot cleaner and it leads to maybe some better options. It doesn't really save us anything. We were at 41%, we're dropped down to 37%. We do better in memory though. Okay, so this is a lot cleaner. It also leads me to think there's probably a better way to do this. What else can we do in here? Well, we could probably exit early. If our result starts going below our current result, then we can probably just exit. Let's try that. Let's see. Oh, interesting. So I was going to move the score dishes out here. So we'll have our score. We'll actually calculate the score. And now if this score is greater than result, or let's say if the score is less than result, we'll just break. It means that we're into negative, more and more negative values. Otherwise, we can just set our result equal to the score. Let's try this. Oh, we're down to 10 minutes. I still have so many things I want to do. Let's go with dishes. Okay, this still works. Let's see if this gains us anything. Probably not. Yeah, not really. 38%. But we're making this function call here. What if we just move our entire function into this so we don't have a separate function call? So we'll keep score out here. Actually, we can do this. Yeah, and we don't need to return score because we're going to use it directly. So this is our same score calculation. Now we don't need this anymore. Okay, we'll start time at 0. Our score will start at 0. We'll do our for loop and then check our score if it's better than result. That'll save us one function call. Might save us a little bit. Let's see, oh right, I no longer have the argument dishes. I only have current. Okay, let's see if this saves us anything. Again, probably not, but this is leading somewhere, I promise. All right, so it still works, doesn't save us anything. But what does this tell us? We've got a for loop embedded in a while loop. I would like to get rid of this for loop. So one thing to note with this for loop, so we're passing in, let's say in our first set of current, we're just going to pass in something like A. And then in our second current, we're going to pass in B and A. So A keeps getting pushed to the end and B gets appended to the front. And then in our next one, we'll pass in C, B, A. Now, we've already calculated BA, and we've calculated A, so I'd kind of like to save this calculation again and use it again. You know, I don't want to have to do that recalculation. But how do I do this recalculation? Or how do I leverage my previous calculation with this new calculation? Because all of the coefficients change. Like this B is now multiplied by 2 instead of by 1. Let's break this down a little bit. So in our first time through this for loop, we're going to be passing in A, and the score is just going to be A. The second time it's going to be B plus 2 times A. And the third time we're going to have C plus 2 times B plus 3 times A. So far, I'm not really seeing a great way to leverage this, but let's break this out a little bit further. So this is still just A. This is B plus A plus A. And this is C plus B plus B plus A plus A plus A. Now, one thing with multiplication is just addition on a loop, right? So this 2A is really just A plus A. This 3A is just A plus A plus A. That's kind of like a loop. We've got this loop and we've got this loop. Is there a way that we can leverage this? I'm kind of starting to see some ways to maybe leverage this. So again, this A at the first one is still just A. But this second one, we've got B plus A as our sort of base plus A. So this is carryover from our first. Now down here, what's interesting is this is C plus B plus A plus So that's C plus B plus A plus B plus A plus A. So that's B plus A plus A. Now you can start to see a pattern. Now this is kind of a mental leap, I understand, but if we look at this pattern, this CBA, this is just the sum of our dishes so far. So each dish is added, and this B plus A is the previous value. Just as this B plus A is the sum of our dishes so far, and this A is just our previous value. So if I were to extend this to D, right? If I had D, C, B, A, I would expect this to be, well, let's see if we can actually do it. I'm going to skip this one. Well, maybe I won't skip this one. So D plus 2C. Oh, we are running low on time. Maybe I will skip this. All right, I ran out of time on my Pomodoro, but I wanted to complete this, so bear with me. Hopefully this will work out. So it looks like, based on the math, that if we keep track of a running sum of our dishes and add that to the previous score of the dishes, that should give us the right answer. Mathematically speaking, it shows that, but it seems a little bit awkward, so let's try it. All right, let's see. So we'll keep a current sum, start it at 0. And we'll keep a previous score, and we'll set that to 0. Okay, so this current we don't need anymore. We're just going to keep track of our current sum of dishes and our previous score. Okay, so our current sum here will just be adding our current dish. And we need to unwrap it from this list here. Okay, so our current sum will just be the current sum from the previous loop plus our current dish. All right. Now our current score is going to be the current sum plus our previous score. And now we can increment our previous score, or update our previous score is now equal to our current score. All right. So just again, we're keeping track of a current sum. So that's the sum of each dish in turn added. We have our current score, which will be our current sum plus our previous score. And then we update our previous score to be this whole thing. All right. And now our result will just be the maximum of either our result or this current score. Wow, this is a big leap to go from calculating a bunch of scores based on dishes and their times to keeping track of the previous scores and just doing this mathematically in one loop. And we don't need any of this. We'll still need the index update. All right, well, let's give it a shot. Let's see, current score. Hey, that works. All right, let's submit this and see if we can do any better. 61% and 98% from memory. Okay, it's an improvement. It's not as great as I was hoping, but there's still some things we can do. So one thing, we can clear this out. This definitely will give us a little bit of an improvement. Let's see, we'll still have this. We don't need our max index anymore, do we? Or we can just set our index directly here. We don't need to have two separate things. All right, we'll have our current sum. Sometimes changing the names of these things can help, but that's okay. I think well, let's try this. Let's just see if this gives us anything. We really only changed a couple minor things. 73%, that actually is getting us closer. All right, one thing we can try here is this maximum. Let's do our own max calculation. So let's see if our current score is less than or greater than our result. Then we'll set our result to that current score. Let's see. Yeah, we can just do this. %55%. Whoa, that was a huge hit. Let's see. What if we did the other way around? If our result is less than our current score. I think we can actually break out early also. Yeah, let's try that. Let's try this, and then let's try an early return. Yeah, 58%, that's not saving us anything. Let's say, if it's less than, we'll update it. Otherwise, we'll break. $95%. That was the key. We early return. As soon as we start seeing scores that are going down, it means that we've passed that threshold in which we can get a better score, and we'll just exit out early. Awesome. 95% for runtime, 46% for memory, not too bad. So we started out, let's go back to our submissions here. So we started out with this big block of code that sort of went through finding indices into an array of dishes, and we slowly whittled that down until we got to just some basic math that calculates the sums as we go. All right, I know this was a long one, folks. Thanks for bearing with me. Thanks for sticking around. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.